Hi guys, welcome to another Learning Electronics Repair video. I have something a little bit different today because I'm proud to announce that Learning Electronics Repair now has a sponsor who are going to be sponsoring some of the videos I make, which will help me make better videos and also give us some very interesting things to look at. So the company who approached me, not the first I will say, I had a few inquiries all over a short period of time, but the one I thought best suited this channel and what we do is PCBWay. So PCBWay are a Chinese PCB manufacturer aimed both at the hobbyist and the inventor, and also for production runs of PCBs, everything from single-sided to 40-layer advanced PCBs, flexible PCBs, and they can do lots of things. And I'll show you them around their site, but they've sent me a few things out of their module store to have a look at. So these are products which they have and you can purchase, and these are based on designs from people who've submitted their designs to PCBWay to make the circuit boards. So I'll show you what I have here. Then let's have a look at the website and I'll explain how it works and why I think it would be very interesting to you guys watching this channel, and also advantageous to the things we can actually do on the channel. So they sent me a little mini plate preheater. This is a USB powered device. If I can just get into the box one moment. It is very well sealed. I'm sure I can find something to get it inside here. And this is a USB powered preheater heating plate, and it's tiny. This is a tiny little thing, so we can have a look at this. But as I understand it, this is hot enough to melt solder, so maybe we can use it to reball some BGAs, or we can actually unsolder some components from small PCBs. So we can have a look at this little thing. We also have a little oscilloscope. So this is a budget oscilloscope at a sort of $20 odd sort of price. And again, this was from PCBWay. And I'm quite interested to review this to see how suitable this is for beginners who just want a small oscilloscope, who don't have the budget maybe to buy a large professional one. But let's see if this is suitable to be used for repair work. And the last thing they sent me is a little board. This is called Espotek Labrador. Now this is tiny. This is a USB device, and from what I understand so far, you attach this via the micro USB cable to a PC, to an Android device, or to a Raspberry Pi. And this is an oscilloscope, a logic analyzer, multimeter or digital voltmeter, and it has a number. It's also a power supply, so this kind of like does a number of things. I didn't mention it's also a signal generator as well, maybe useful for amplifier repair. So these are things we have here to play with on this video. This might have one to itself, I will say. But first, let me show you around the PCBWay website and why I think it would be of great interest to you guys who are watching this video and who watch this channel. This is PCBWay's website, and as you would expect, they manufacture PCBs and also offer complete PCB assembly, but they have quite a lot of products and capabilities on here. So if we have a look, we can have a look down here. They will make all sorts of PCB, including PCBs that effectively are heat sinks for LEDs, for example. And they also will make stencils, SMD stencils. They have laser stenciling, where you can effectively send them the layout for a stencil, I would imagine, from the actual photograph of a BGA. And these guys can make the stencil for you for reballing. All sorts of PCB assembly, and they also do CNC and 3D printing, so they can help you to produce enclosures for your projects, and really the whole range of services that a hobbyist or an inventor or somebody producing small or large numbers of PCBs would require. But there are a couple features of this website that I really like, and I think this is where it comes into its own for hobbyists, and the possibility of on our channel getting involved in making some projects, some cheap, inexpensive but good quality test equipment, for example, and I'll talk about that in a minute. But let me just show you around the basic use of the site. So we have an instant quote facility. This is quite nice. So if you want to make some PCBs, effectively you put the size in here. So in millimeters, let's make some PCBs. So 80 millimeters by 60 millimeters. I'll just pick some numbers. We can choose how many PCBs we want, from 5 upwards. Let's go for 10. And you see it's saying get 5 free prototype order. We can have 2-layer PCBs up to 14 layers, but let's go for some double-sided PCBs. We can choose the thickness of the PCB. 1.6 millimeters seems to be the standard one. And let's have a look. We can just hit the quote, and this will then take us into the quote. It looks like we have to enter the same information again. Interestingly enough, perhaps we should have just hit quote. But let's go again. Just we want one design. That's the size we've already put in, so actually we didn't have to do it twice. The 10 PCBs, double layer. This is the various materials we can choose, a number of options, but let's just leave all this as it stands, just standard green PCBs. And you can see straight away that the 10 PCBs, build time of 24 hours, are going to cost $5. Plus a chunk of postage. This is the USA, so it's giving me a price of $25. I can actually choose I'm in Spain. We can choose I'm in Spain, for example. I can choose various shipping methods. If I want to wait a bit longer, I can go for the PCBWay Express. Save a little bit of money. It takes 10 more days to get here. Depends how urgent the thing is for me, really. And look, it's now $18. So you can basically enter in here what you want, the size, how many layers, the basic parameters, and it will give you a quote. It does say this is subject to review. Great thing about this site is when you have your quote, you'll see the process. So you get the online quote, you upload your PCB file, your Gerber file, your layout file. They then review the order, so their expert technicians will check out to see if your design is good. I mean, I'm very much a beginner at PCB layout. I've done a little bit of it, but not very much. So they will check over your order, and if it's fine, they will then request payment for the order. After that, they fabricate the items and they deliver it. If there's some problem at this point, they'll get back to you and explain what the problem is, and then you can review your work. You can see they will suggest also what you need to change on your PCB layout, and then you make the payment. So that's great. It means that by the time you make a payment, they ask for money, you already know that your PCBs are going to be usable and they're going to be suitable for the job that you require. So that's the basic system, how it works. They do CNC machining, as I say, 3D printing, and you can see the prices to give you an idea. They will also assemble the PCBs if you want to make large productions. They will assemble them, they'll actually source the components for you and build the completed items. Now, the clever things I mentioned, why is this website good for us hobbyists? And that's this. In particular, they have an option to share projects. So if we're going to share projects, you will see, it takes a moment, okay, we're in the shared projects, okay, and here you can basically upload your project. So we can go to projects here. DIY electronics is a good example. Let's find something. PCB device to test continuity in circuits and polarity of components. Yeah, this is some of these projects, so we can look at this. So this is the PCB. You'll then find the bill of materials, the components required that you can order from elsewhere, or you can have the whole thing. Any software that was required, if it's a microcontroller based project, you'll have the software. It's all open source. This is all open source. This is a description of this circuit, how it works. You'll have the schematics, and everything's there for you to build this project. Now, the great thing is that if I come along, for example, and I like this project, and I come in here and I order from here, as you can see, PCBWay will donate 10% of the cost to the author. So whatever I pay, 10% will go to the guy who designed this. So if you want to make little prototype items or small production items, you don't have to go to the expense of ordering, say, 50 or 100 PCBs hoping you'll sell them. You can just put your design on here. You can advertise on social media or where you like, or on the YouTube channel. And they're available to anybody in the world there. And I think that's a really, really nice feature that suits the type of channel that we have here. Another interesting thing is on the same lines to this actually, but PCBWay will also sponsor projects. So this is the information on sponsorship. They will sponsor non-profit projects, and they will also sponsor crowd-funded projects. And you can see they have many sponsored projects. Now, I had a chat with PCBWay when we were discussing sponsorship for the Learning Electronics Repair channel, and one thing they would be very interested to do is to help us with any projects we may have. For instance, if we want to build signal injectors or similar little projects, test equipment, then they would be interested to get involved with those projects. I'm sure quite a lot of you are aware that Learning Electronics Repair has a Discord server. So this is the Discord. You can see at the moment there's many people online, and there's many members of the Discord community. One of the reasons I decided I would really like to get involved with PCBWay is the possibility of using the Discord server. We have a community here, and the YouTube channel, to bring some of you guys together, maybe if you're interested in developing and producing bits of test gear and anything we can think of that just helps us in repair work. So I hope that some of you would be interested in that sort of project, and if you are, please mention in the comments below, and I'll set it up so we can get involved maybe in a number of projects simultaneously on the Discord. And then if we have something we think is going to be really cool, then we can ask PCBWay if they would like to be involved in that project as well. There's another nice thing about PCBWay as well, which is that if you order PCBs, you get tokens. They call them beans. These beans, these are kind of like loyalty rewards. And as you build up the loyalty rewards, you can then order things from their store, and you can get things for free. You'll see the hotplate preheater there. These are some of the items that are in the store. So I'll just show you what they have, and you'll see some things here. And this is the little oscilloscope we're going to look at now. And also we have the little Labrador board which we're going to look at as well. But there's many things you can get for free as a reward for ordering your PCBs from PCBWay. And here is a really cool thing. I'll put a link in the description to this video to PCBWay, and if you follow the link and register as a member on their site, this will give you all the advantages of being able to share projects and everything else I was just discussing. But you will also get a free gift of $5 in tokens, which you can use against your first order. So for example, if you want to make some PCBs, up to $5, they're free. You just pay the postage. And even better, I was chatting with PCBWay, and the items I'm now going to review are also included in the offer. So if you're interested in the oscilloscope or any of the other items you're going to see now, just remember that if you register with PCBWay through my link, you will get the $5 discount voucher, which you can use against your purchase of one of those items. Now we've had a quick look around the PCBWay website, some of the products they have, the facilities they have, the ways in which they can help you with your own projects and inventions, and the ways in which you can make money from your own projects and inventions. Let's have a look at the items they kindly sent me and see if they are of help to our electronics repair work. This is the little oscilloscope. So these are between 20 and 30 euros, 20 and $30. And it's quite a nice little device actually. So the specification I will just show you of this oscilloscope, and then let's try it and let's see if it's actually of use in fault finding on the stuff that we're likely to be working on. I'll attach the oscilloscope to the USB power and we can switch on, and you see straight away we get a display that's very quick to boot up. I'll connect the probe to a signal generator. I have a signal generator here. Let me just click the ground on as well, and then we can have a look to see how this is working. So I have my generator at the moment set to a triangle wave. I'm sure I can choose some other wave, sine wave, square wave. Okay, let's go with a sine wave for now. So the first thing you'll notice is it has an auto mode, and this is quite nice. If you press the auto button, hold it down, it says it will calibrate. So in calibration, you remove the lead and press OK. This now calibrates the unit. Okay, done. Now let's attach the lead again, and if we just press the auto button rather than holding down, it now goes into auto mode. So it's trying to find the best settings to display the waveform, and there we have it. So it's got 100 millivolts, 50 microseconds. If you hold in the run button for a couple of seconds, you can actually now read the maximum and minimum voltage and a few other things, the cycle, the duty cycle, the frequency of 10 kilohertz. Now I have my signal generator set to 10 kilohertz. Let's have a look to see now if we take the frequency up, so 20 kilohertz, and that's absolutely fine. So I'm sure this would work very well at audio frequencies and be a very useful tool for audio repair. What I'm also interested in is how useful this would be when working on VRMs, buck regulators, switch mode power supplies. Now these normally work from 100 kilohertz up to almost maybe 1 megahertz, somewhere in that range, and this says it has a bandwidth of 200 kilohertz. So what happens if we go above that? Does it just stop at 200? Does it not display anything? Well, let's take a look. So I'm going to take up the frequency on my signal generator, so let's go up. So we now at 100 kilohertz. Again, let's just press auto. I could manually range it to increase the time base as I was showing you, but let's see how well auto actually works. Yeah, it's working fine. So let's go up some more. So we'll take it up to 200 kilohertz. This is the limit for this. Apparently it's reading 199, 201, so it's reading, telling us basically 200 kilohertz. We can increase the amplitude a bit if we like. What happens if we go above that? Well, 210, 250, it's still working. I'm now at 300, and it's quite happily displaying that. In fact, it's giving us a frequency of 300. What happens if we go up, say, to 500? Does it eventually just conk out? Let's have a look. Well, that's at 500, and it's now reading. Okay, the accuracy is not there, but it is showing us we have a signal at 500 kilohertz. So this would tell us a VRM is running. That's handy. And what if we go to square wave? again, yeah, it's kind of like losing some stability, but it's still running. Let's push us way past its rating. Let's go up to, for example, up to megahertz. I'm now at 1 megahertz, and it's still at least shows a signal, but it will no longer display the frequency. What it will do, if I disconnect the probe and reconnect the probe, it will tell us that there is a signal there. Just get back onto it. So I would think for power supply repair, quite often we're not particularly interested in what the waveform looked like. We just want to know the waveform's there, yeah, not what it looks like. So let's actually try this on some real life repair. Let's get a motherboard and let's see how useful this little device actually is for repair work. This is the motherboard we use for testing graphics cards and similar. So I'm going to check our little oscilloscope on the motherboard, taking some common measurements to see how well it actually works. So I'll just switch the board off because it happens to be on at the moment. I'm going to be using my oscilloscope probe, but mainly because it's just easier to probe onto the chips. There's no reason why you couldn't use the little cable that came with this and just use like the stiff leg off an LED or some stiff bit of wire to press against the chip. But to be quite honest, if you're going to buy one of these, you know, an oscilloscope probe isn't a big consideration. So let's get our scope probe onto the chip select of the BIOS chip, and let's see if this will tell us whether it's reading the BIOS. Oh yes, and quite clearly we can see there data going on. So without a doubt this is telling us if a BIOS is being accessed. That's very useful on GPU repair and motherboard repair and other uses. So we are quite easily using this for that purpose. Let's have a look at a VRM. So let's go over to the main vCore VRM. I'll just click my probe on it. One moment. It's going to be difficult to get into camera, but I'm sure you can trust me when I say that I'm actually on the vCore. Okay, I'm on one of the MOSFETs. Let's see what it thinks. Will it see it? Yeah, straight away. I mean, it's gone off the screen a little bit. I mean, I'm sure I can adjust it. But it's definitely telling us that VRM is running, and that's what we wanted to know. I can adjust the voltage setting. We can have another look. One moment. Just change the settings on this. Change. Yeah, let's go up a little bit. I've gone to 1 volt. Okay. I think we just have to press OK to come out of that. I'm not quite sure. I haven't used this very much. Now we press the change again. That will do. Okay. Let's tell it to run now. So I'm on run mode. Let's see. Again, we'll go to our VRM. Just get onto one of the MOSFETs. And let's have another look. So I'm on the MOSFET. Switch on. Yeah, and very clearly it's telling us that that is running. It's telling us it's running at 304 kilohertz, which I just happen to know is about right for this board. So this little device, in my opinion, is actually performing well above the rated bandwidth of the device. And for fault finding on motherboards and such like, this is a really useful little bit of kit. Where I can see this coming into its own for me in particular is because I can use this on the hot side of a power supply, ATX power supply switch mode. I can connect this to hot ground and I can probe around safely on there, especially if I connect it to a battery, which is what I think I will do. I'll fit a battery on the back of it. You can get the version with the battery already in. I'd say that's probably a good idea if you're going to use it for that sort of use. You may be a little bit concerned that you have this bare metal work, but to be quite honest, if you're working on a switch mode power supply, you have the thing open with a bare PCB with lots of high voltages present, and you have to be no more careful in using this, in other words avoid touching the metalwork, than you have to be careful in working on the power supply in the first place. So in my opinion, if you're confident on working on that sort of circuit, this is no more dangerous than the device that you're actually trying to repair. I hope you guys like this little product as much as I do. Considering how inexpensive it is and how well it worked for the sort of repair work that I do and that I'm teaching to you guys, I think it was exceptional. It performed well above my expectations. So I'll place you the link on this one to PCBWay. Maybe you're interested in that product, and it's open source again. There's lots of firmware we can look at on that, maybe to upgrade it. But as it stands, I think it worked just great. So we have that, and I started the video. We have this. Now, this little Labrador board has so many functions. I'm going to put this on its own video. Let me know if you're interested in seeing a review of this, and if you want to see the review. But this, as I said, is an oscilloscope, a logic analyzer. It analyzes serial data and actually gives you, the data. It is a function generator, and it's also a multimeter that displays on Android, on Raspberry Pi, or on your PC. So if you'd like to see a review of this, and to be quite honest, probably if you wouldn't, because I want to try it anyway, we'll put that in its own little video. But we've got enough time on this one just to have a look now at this. So this is the Mini Hotplate. Tiny little thing. So let's get this plugged in and let's see how well it works. Of the mind, this is probably designed for little PCBs like mobile phones and such like. But I'm pretty sure I have something here we can test it on. And let's see if we can actually desolder some components with it. So this comes with a quite hefty USB charger. I bet this will charge my phone pretty damn fast. What is it? It's a USB 5 volt 3 amp. No, it's a variable power supply. It's not actually a USB as such. You can see the ratings on it. It goes up to 15 volts, 20 volts. Yeah, I wonder if it doesn't have like a range select. Maybe it's an intelligent power supply of some sort. So we have that. And we have a little cable that came with this as well. So let's have a look at the... I'm guessing this is just a rubbery USB C-type cable thing came with it. And we have a little instruction book. So let me have a look to see how to use this, and then let's give it a go. Okay, it comes with some instructions. So this is basically telling us that it has 3 preset temperatures at factory setting, 220, 250, 300. And it's, well, shall we see if we can figure out how to work this? In standby mode, press button A, start, default is M1, which is 220. Select temperature preset. In heating mode, press B. No, sorry, press button A to choose M1, 2 or 3. So let's go for the middle one. Temperature adjustment in heating mode, yeah, so holding B, you can change the temperature. Let's have a play with this on the preset. So we'll, yeah, we have some buttons on the back, A and B. A switch is on. Let's have a play. Okay, so I've plugged it in, it lights up green. Oh, it now says it's hot. Warning, heating 30 centigrade. Okay, I'm just looking at the display on here as you guys are. I think it says, yes, it's going M1, M2, so that's the temperature range. So we can see this is actually warming up. Let's see how long it takes to get to temperature. I'll take my little temperature meter as well so we can just check it. The display is saying 78. What's this telling me? Well, it's certainly getting warm, that's for sure. You can probably see it. So this is showing me the temperature. So the actual temperature seems to lag the display temperature a little bit, but it's certainly getting hot. While that's warming up, let's find a little PCB or something we can put on top of this and then see how well it actually performs as a soldering or desoldering device. Well, the light's gone red, which I think indicates that it's hot. The temperature is 257. And on my temperature meter, just so you can see it. Okay, it's going above 200. Let's stick an old PCB on. So this is off an old hard drive. Let's see how well this actually works on our PCB. Let's see if we can desolder some components with it. Let's bounce it on there and see how long it takes to warm up. A little bit of flux might be a good idea while we're doing this. Flux on here somewhere. Okay, and let's see how long it takes to actually do something. Well, it's been on there for a minute or so. There's definitely smoke coming off it now, so it's warming up the board. The flux is obviously heating up. Let's see if we can actually desolder some components with this. Okay, so it's been on for a few minutes now, but we're not actually getting to the point where the solder becomes liquidous. Let me see how hot this actually is. So we'll just get in here. And it's about 190, which isn't enough to melt the solder. So I'm going to just switch the temperature up. Another quick press on button A. I'm now in M3, mode 3. So this should increase it up to its maximum. Okay, so I've given it another minute on maximum. Now let's see if it's... Yes, it is desoldering components. So this is clearly intended for small devices, mobile phones and such like come to mind. But it certainly will desolder devices from the board. Yeah, we can take some resistors and such like from here with the tweezers. I would say that one of the nice things about this little device is there's no airflow, so it's going to be very good for changing small BGA devices and similar. I doubt it would have enough heat to work on large PCBs. It's something I can try later when I have something suitable, but for now you can clearly see it's doing what it should do, but only to the chips that are over the board. Okay, so let's switch it off and then let the board cool down, and then let's see how the PCB withstood the heating. In fact, I'll take the PCB off the device now and we'll just put it on one side and let it cool down. Okay, and here's the PCB. Although we heated it from below, I mean, there's no damage to the board, it's absolutely fine. It made a very good job of removing the components without any damage, I think. We can zoom down and have a quick look. In fact, we can have a look under the microscope. So, yeah, it's made a nice job of removing that RAM chip. It's very clean. I'm absolutely certain that this could solder replacement chips no problem whatsoever. And the fact there's no airflow from above means it's not going to blow around while you're soldering it back in place. So I would say, without a doubt, the product works for what I believe it's intended to be used on. Again, actually, I was quite impressed with this thing for being so small as to how well it worked on this PCB. I'm not totally convinced it would work on large PCBs, graphics cards and things with heavy ground planes in, but I would have to try it. I haven't tried it, so I can't judge it on that at the moment. Certainly localizes the heat in a small area, and as long as the heat's not being dissipated away too quickly, it will do the job. What I did like is the fact that it doesn't produce any draft like the hot air, and also my preheater underneath, which is hot air, causes some vibration where this is absolutely still. So I'm quite convinced for chips like these sort of things it'd be well capable of soldering one of these, desoldering and replacing, and making a good job of it. Whether or not it would do that on a laptop board with EC or SIO, I need to try it when I have the next opportunity. It certainly got me interested in hot plates. I don't have one, and I'm now quite keen to try a larger one to see how well that works. But if you're repairing mobile phones and small boards like that, I think this is a really great little tool, and I'm sure I would be using it for that purpose, which is what I think it was intended for. I hope you enjoyed that video, guys. I think we have some interesting products there. I was impressed with both of them in their own way, but for the sort of work that I'm doing, this little oscilloscope I think is a winner. I'd like to thank PCBWay for sponsoring this video and the opportunity to look at some of these products. And I really hope that some of you guys are interested in getting involved in some little projects where we can use their facilities to make some very interesting little devices. So let me know, as I mentioned before, in the comments below. Let me know, and I'll get onto Discord and we'll make a section where we can get together and discuss that. And let's see what we can put together between us. Yeah, more heads are better than one. Okay guys, I'll see you all soon on another Learning Electronics Repair video. And just one more thing to say, ciao for now guys.